Hi. So this course which I'm planning to give, it's called Mathematics of 3D Gaussian Splatting. If you've been working on 3D Gaussian splatting, or at least you've come across 3D Gaussian splatting in general, which has been creating a lot of buzz recently. And if you've been wondering what is the underlying mathematics of this, where does this, how do I understand the math? What is actually a 3D Gaussian? What are basically camera projections? What are the covariance matrices, Jacobians? What is alpha compositing? What is spherical harmonics, quaternions? All these terms you come across 3D Gaussian splatting papers very frequently. So you've been asking, what does all these equations mean? Or is there a systematic way of understanding the mathematics behind 3D Gaussian splatting? So these are the kind of questions which I'm trying to explore in this course. So we'll bring some of the foundations of linear algebra, multivariate calculus, covariance metrics, ideas from graphics, bit of camera geometry, and bit of volume rendering. All this is required to actually build the pipeline for the entire 3D Gaussian splatting pipeline. Come across all these concepts and equations at various stages. And initially, we'll look at all this. We'll systematically build all these concepts, and then we'll deal with the static Gaussian splatting pipeline. And over the past few years, the field has moved to dynamic Gaussian splatting. So we'll also build a theory for dynamic Gaussian splatting. And if you're looking for something which is very, visually explaining, uh, with a lot of explaining how the code work, how the architecture is, how the models work. This is not the, of course, this is not the right place for it. Maybe you can find a lot of other stuff on internet for that. But if you look at internet for a hardcore mathematical course in Gaussian splatting, you hardly find any. This is actually an attempt to do something like that. So if that sounds useful, let's get started.